Electric circuit. The closed conducting path in which the electric current flows is called an electric circuit. An electric circuit constitutes of a source of electric current, cells, etc., a conducting wire, an electrical appliance, bulbs, etc., a switch or key. When the switch is closed, the circuit is said to be closed circuit. In this condition, current flows and appliance works. Example, the bulb glows. However, the circuit is said to be open circuit when switch is open and there is no flow of current. Source of electric current. A device that produces an electric current is called a source of electric current. Example, cells, batteries, etc. Battery. When two or more cells are used to draw an electric current, the combination of cells is called battery. In battery, positive terminal of one cell is connected to the negative terminal of the next cell. Many devices such as torches, transistors, toys, TV remote controls use batteries. Bulb. It produces light and is represented by coiled wire inside the circle as shown. Connecting wire. The connecting wire is represented by a straight line. It is usually made of copper and provided with insulation. Plug key. A plug key is an electric switch. It is shown in both on and off positions in figure. Cell. A thin long line represent the plus terminal and thick short line the negative terminal as shown. Battery. A combination of two or more cells is called battery. Its symbol is also a combination of cells symbol as shown. Fuse. It is safety device in electric circuits. The components such as cells, bulbs, wires, etc. are called elements of an electrical circuit. The various components of the circuit are represented by standard circuit symbols. It is much easier to draw a circuit diagram using symbols. Therefore, we generally represent an electric circuit by its circuit diagram as shown. Symbols of some common components are shown. Heating effect of current. When an electric bulb glows continuously for a long time, it becomes very hot as some part of the electrical energy is converted into heat energy. This is known as heating effect of current. The heating element in many electrical appliances like electric rod, electric oven, electric toaster, etc. is made of nichrome alloy. Take a 10 cm long piece of nichrome wire. Tie it between the nails. Now touch the wire and switch on the current in the circuit by moving the switch to on position. Touch the wire again. Do not hold the wire for a long time and switch off the current. Touch the wire again. After a few minutes, we will observe that the wire becomes hot when an electric current passes through it. This is the heating effect of the electric current.
Safety devices.
Mini circuit breaker used to protect circuit from strong current. Strong current often leads to overheating of wires, which can result in the breakout of fire. Fuse also used for protection of circuit, which consists of a thin wire of low melting point. In 1820, the Danish physicist Hans Christian Ørsted discovered that flowing current in a conductor generates a magnetic field. Ørsted demonstrated this by connecting the two ends of wire to a cell through a switch. Then he placed magnetic compass near the wire. Now when he allowed the current to pass through the wire by closing the switch, he observed deflection in magnetic needle. He also noticed that it requires its original position when the flow of current is stopped. Take a discarded matchbox and wind an electric wire a few times around the cardboard. Place a small compass needle inside it and connect the free ends of the wire to an electric cell through a switch. Note the direction of the compass needle. Bring a bar magnet near the compass needle. we will observe that the needle gets deflected. At the same time, move the switch to the on position. We will again observe that the needle gets deflected again. Now move the switch back to the off position. We will observe that the needle comes back to its original position. So, we conclude that when electric current passes through a wire, it behaves like a magnet. Take the tray from inside a discarded matchbox. Wrap an electric wire a few times around the tray. Place a small compass needle inside it. Now, connect one free end of the wire to the terminal of a battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. Insert free end of wires into half cut of potato and observe. You will observe that a compass needle gets deflected and also find that it was always the wire connected to the positive terminal which has greenish blue spot around it. They felt that the discovery was very useful because it could be used for identifying the positive terminal of a cell or a battery concealed in a box. Electromagnets. Current-carrying wire or a coil of wire behaves like a magnet. If a permanent magnet is brought near the coil, one end of the coil gets attracted and the other end gets repelled. This shows the opposite polarity of the coil. If a piece of soft iron is kept inside this current-carrying coil, the iron piece gets magnetized temporarily. Such magnets are called electromagnets.
Electric bell. An electric bell is one of the most commonly used applications of electromagnets. It works on the magnetic effect of current. It produces a repetitive buzzing or ringing sound when an electric current is passed through it. Electric bells have been widely used in telephones, fire, and burglar alarms, at railroad crossings, as doorbells, school bells, and alarms in industrial plants, but they're now being replaced with electronic sounders. An electronic bell consists of an electromagnet, springy iron strip, a hammer, a gong, and a switch. An electric bell works on the principle of electromagnetism. It is a simple device which has a U-shaped solenoid, one end of which is connected to a spring of the switch, and the other end is connected to a soft iron armature. Basically, all the components such as the switch, electromagnet, hammer, soft iron armature, and spring are connected in a circuit to make an electric bell. When electric current is allowed to pass through the circuit, the iron core of the solenoid gets magnetized and pulls the soft iron armature, which causes the iron hammer to strike the gong. When the armature moves toward the poles of the solenoid, the circuit breaks and the solenoid loses its magnetism. This forces the armature and the hammer to return back to their original position.